Welcome from Maths and Science by IITian. In this, we'll develop another concept. Till now in the last two lectures, we have understood how a complex number is represented in a complex plane. And now, let us try to define some inequalities in this lecture. Two inequalities we will be defining in this lecture. First inequality is one complex number is Z, let us say, another is W. These are in the complex plane. The modulus of Z plus W is less than or equal to modulus of Z plus modulus of W. That is the first inequality we are going to discuss. The second inequality, what we are going to discuss in this lecture is modulus of Z plus W is greater than or equal to whole modulus of Z minus modulus of W. These two inequalities are very, very important, not only in the point of view of complex numbers, in the point of view of real numbers and other numbers, number theory for IIT JEE and also for Olympiad. In Olympiad also inequalities are there. In JEE, mains and advanced also inequalities are there. We are discussing about the complex number inequalities, and depending upon the pattern of the examination, they may ask real numbers inequalities, they may ask integers inequalities, they may ask the inequalities representing the rational numbers. Once you understand the complex numbers inequalities, then other inequalities of other smaller set of numbers will be easier for you to understand. Now, let us delve into the problem. Let us talk about the first problem. What is the first problem? If there are two complex numbers, Z and W, in a complex plane, the modulus of Z plus W is less than or equal to modulus of Z plus modulus of W. What is Z? Let us say Z is equal to, let Z is equal to A plus IB and W is equal to C plus ID. I is nothing but iota, that is square root of -1. How do you represent these two numbers in the complex plane? Because both are complex numbers, thinking that C and D are positive real numbers, A and B are also positive real numbers, then A plus IB, one number, Z, and another is C plus ID. This is AB, let us say it is CD. These two are nothing but looking like vectors. It's nothing but vector addition. This is Y direction, it is imaginary values, and in X it is real values. One is A plus IB, W is C plus ID. The addition of OC, this let us say, we will call any point. P. Let us call it as Q. The addition of vectors OP and OQ is the resultant of magnitude of Z plus W. Z is equal to A plus IB. Or OP is equal to A plus IB. We can rather say. And OQ is equal to C plus ID. Modulus of. Now, this is the angle theta 1. Let this angle be theta 2. When these two are added, what happens? The modulus of it will be either equal to or less than or equal to modulus of Z plus modulus of W. It will be very easy. If you take some numerical number here, let us say AB is equal to 3, 4, A is equal to 3, B is equal to 4. Let us say some values. So that you try to understand the concept. C is equal to 6. D is equal to 8. Let us say some arbitrary values. Then, what is the modulus of Z? Square root of A square plus B square. We have already calculated in the previous lectures. Please see the lecture 1 and 2. I don't want to repeat again and again. That is square root of 9 plus 16. That is square. These are all modulus. These are all modulus of Z is equal to 5. Square root of 25 is 5. And what is modulus of W? Square root of C square plus D square. Square root of C square is 6 square plus 8 square. That is square root of 36 plus 64. Modulus of square root of 100. Modulus of W is equal to absolute value of square root of 100. Absolute value of square root of 100. That is equal to 10. Then, what is the value of Z plus W? How you add Z plus W? If some 3 plus 5 is there, you can add it to 3 plus 5, 8. If something is like 8 plus 11, we can add 8 plus 11 is equal to 19. But how to add the complex numbers? Complex numbers are nothing but they are as good as vectors. It's a complex plane. Vector is also a plane. In xy plane, we show the vector. Similarly, in a complex plane, complex number is shown. In vector, how do you write as a vector? Vector OA is equal to x into I bar plus y into j bar. If vector OB is equal to P into I bar plus Q into j bar means vector OA plus vector OB is equal to x into I bar plus y into j bar plus P into I bar plus Q into j bar. What we do? I bar will add together, j bars will add together. That gives x plus p I bar plus y plus q j bar. This is OA plus OB. Similarly, here what is Z? Z is equal to is given as A plus IB. What is W? W is C plus ID. Then for Z plus W, what we have to do? We have to add real numbers separately and we have to add the imaginary numbers separately. That means Z plus W is A plus C plus I into B plus D. Very, very important equation. It is not just a regular addition. If two complex numbers are added, the real part of the complex number is added together and the imaginary part of the complex number is added together. This is the imaginary part. A complex number will have two parts. This is real part. Real part coefficients are added together. Imaginary part coefficients are added together when you want addition of two complex numbers. Now, what is the modulus of Z plus W? That is equal to square root of, it is not square root of Z square plus W square, it is square root of final complex number of real part whole square plus imaginary part whole square. That is, please remember this, A plus C whole square plus B plus D whole square. This is also very, very important one. Now, here, what we have taken as an example, A is equal to 3, B is equal to 4, C is equal to 6, D is equal to 8. In the previous example, if you see, I am explaining with the example also. These are the values. You put them here. That means here Z plus W is equal to absolute value of square root of A plus C whole square. A is 3, 3 plus 6 whole square plus B plus D whole square. That is 4 plus 8 whole square. That is equal to square root of 9 square plus 12 square. Z plus W. When you do it with example, then you will understand the concept very easily. Square root of 81 plus 144. 81 plus 144 is 225. That is 15. Modulus of Z plus W is 15. Whereas what is the modulus of Z? 5. Modulus of W is 10. Modulus of Z is equal to 5. Modulus of W is equal to 10. Modulus of Z plus W is equal to 15. That means in this particular case, modulus of Z plus W, sorry, W should be written like this, small w, is equal to modulus of Z plus modulus of W. This may not be the case every time. If the values of C and D are changed or A and B are changed, the modulus values will change. But at any point of time, modulus of Z plus W is less than or equal to modulus of Z plus modulus of W. Take some more values of Z and W and prove this. This less than, you prove it. It is a triangular inequality. You prove it. Less than, I have proved, is equal to, give some values and prove it. If you want me to try another one, we'll try. Let A is equal to 3, B is equal to 4, C is equal to 7, D is equal to 11. What is Z plus W? Modulus is square root of A plus C whole square, real numbers. A plus C whole square is 3 plus 7 whole square plus 4 plus 11 whole square. That is equal to square root of 10 square plus 15 square. Square root of 225 plus 100. That implies Z plus W is equal to square root of 325. Whereas modulus of Z is equal to 5, as usual in the previous example, previous steps, and modulus of W is equal to square root of 7 square plus 11 square. Square root of 49 plus 121. Don't forget to put mods, absolute values. We have to find the absolute values. Square root of 170. That means modulus of Z plus modulus of W is equal to 5 plus square root of 170. Whereas modulus of Z plus W is equal to square root of 325. Square root of 325 is how much? Approximately you find out. Square root of 324 is 18. Approximately we can say it is equal to 18. And what is its approximate value? 5 plus square root of 170. 5 plus 165 is 13. 13 plus something. Square root of 170 is 13.038. If we are accurate, if we want to be accurate. Square root of 325 is 18.027. This is equal to 18.038. It is 18.027. That means this modulus of Z plus W is lesser than the individual modulus of Z and W. You can take any other values, prove it, go on prove, and you take any value of A, B, C, D. The final answer is the modulus of combined modulus of Z plus W will always be either equal to or less than modulus of Z plus modulus of W. This is what is proved. This is a triangular inequality. If you delve into the algebra, regular algebra, you can prove it with a triangle. When there are two sides of the triangle, and the two sides are added together, then that value will be smaller than the individual sides modulus. This is the triangular inequality. This is the inequality, first inequality we have proved. Now, what about the second inequality? It is like I can rather say it is the magnitude of the vectors. If you have studied your vectors also in your 10th class or 11th class, then also you can easily understand this concept. Then, second is Z plus W total modulus should always be greater than Z minus W. You just see, we take the previous values. Previous values when A is equal to 3, B is equal to 4, C is equal to, A is equal to A, B, C, D. 4 values. We have to give 4 values. 3, 4, 6, 8. A is equal to 3, B is equal to 4, C is equal to 6, D is equal to 8. That means Z plus W is nothing but 3 plus 6 plus 4 plus 8 I. Because Z is equal to 3 plus 4I, W is equal to 6 plus 8I. Modulus of Z plus W is equal to 81 plus 144, absolute value of 9 square plus 12 square, that is equal to 15. 81 plus 144 is 15. The modulus of Z plus W is 15. What is the modulus of Z? Modulus of Z we have found out as 5, refer to the previous one, and modulus of W as 10. Here it is a total absolute value. Because always whenever inequalities are there, it is better to go for the absolute values. We are finding the differences only. Now, modulus of Z plus W is equal to 15. Absolute value of modulus of Z minus modulus of W is equal to, right hand side is equal to, absolute value of modulus of Z is 5 minus 10, that is equal to 5. That means Z plus W is always more than the difference. Here, modulus of Z plus W is always greater than modulus of Z minus modulus of W, the whole value is absolute value. This we have proved with. As a homework, please find A, B, C, D such that modulus of Z plus W is equal to absolute value of modulus of Z minus modulus of W. Please do this as an exercise. When you do it on your own, you learn more. And I have proved Z plus W is greater than, modulus of Z plus W is greater than absolute value of modulus of Z minus modulus of W. Now what we have to do? You have to prove. Here I say, this is what I have done. I did it. Completed. Don't worry about this. Now, you find A, B, C, D in such a way that modulus of Z plus W is equal to absolute value of modulus of Z minus the modulus of W. Please do it. This type of questions only will come in your examination. It is you have to sit in the examination and you have to do it. Please solve this problem. Now, inequalities are over and meanings of complex numbers is over. Now, in the next lecture, we will go for organed plane. It's a complex plane is there. We will go for defining the radius of a circle and organed. We will go for it and we will go for the, before going for the polar forms, we will go for some good numerical of the standard of IIT, JEE, mains or advanced or Olympiad and CBSE. Definitely we will go for a very good example in the next lecture to the next lecture. In the next lecture, we will go for organed. Circle. Argument. In complex plane, what is the argument? Circle, organed, and argument. We'll discuss these things in the next class. Best of luck to everybody. Thank you for viewing my channel, and my channel name is Maths and Science by IITian. Let us go slowly, but let us